Hi everyone, my name is Dimitri, and I'm going to talk about the art of PostgreSQL today. So maybe you've been using PostgreSQL for a while, and maybe you are an application developer. This talk is mostly intended as PostgreSQL developers who are writing code, making an application, and using PostgreSQL. So we're going mainly to see about things that relate to this position. If you're a DBA or in a management position or something like that, the first part of the presentation will still go through some of the basics around PostgreSQL, so you will possibly like that part a lot already. I've been using PostgreSQL and contributing to it for a long time now, so I began in the previous century, really. And I'm currently working at Citus Data that has been acquired by Microsoft. So you can check that out if you want to. Currently, I'm working on a couple projects around PostgreSQL as a way to contribute to the community. One of them is pgAuto Failover. As the name implies, it's a project that allows to deploy automated failover for your PostgreSQL instance in production. So if anything goes wrong with your primary server, then you need the application to connect to the secondary and the secondary to be promoted. Orchestrating that can be a little complex, and pgAuto Failover automates this setup. So if that's something you want to do, check it out. Another project I've been contributing to for, I think it's 15 years now, is called pgLoader. The idea is to load data into Postgres. And when you do that, then there is a whole lot of use cases related to migration, like migrating from one database to another one. It's one way of loading the data, right? So you can do a full MySQL to PostgreSQL migration in one command line that is shown on the slide. So basically, you just give us the source connection string. In that instance, the source is a MySQL database, and the target connection string, in that instance, it's a PostgreSQL database. And then here is what happens. So it's a little small to read every detail. The important part is that we just scan through the whole schema with pgLoader and then basically create the same schema on the other side and then fill in the data and then complete the migration with the indexes and constraints and foreign keys and etc. It's all in one command and it just works. So if you need to, consider using it. This conference slide set has been prepared from my book, The Art of PostgreSQL, that I've written and published. And so if you like this conference and want to dive in more into what you can do with PostgreSQL as an application developer, check it out. Also, if you want to, you can use a special discount that I have set up for Postgres Vision 2020. So it's PG Vision 20, and you have a nice discount, and it's going to be available this week only. So check it out. Right, so now let's get started. The main topic I want to address first is, as an application developer, I've met with a lot of them. I used to be a consultant, so I used to go and fix databases or help people fix their database and things like that. And as a developer, when you're using PostgreSQL, often enough, you don't get to be asked why PostgreSQL. You join a project, they're already using it. There is a stack that is in production already, you're contributing to it, or maybe there is a company-wide policy that, you know, an application should use a database, and this database is going to be PostgreSQL. So in many cases, as a developer, as an application developer, you're using PostgreSQL already, but you don't have the chance to ask why, really. So I wanted to address that point first. The reason why we use a database is concurrency and isolation. Some people, when asked the question, will tell you that a PostgreSQL or a database is good at storage because they have objects in memory and they want to store the objects. Well, if that's your use case, if that's what you want to do, you can always serialize the objects to XML and store XML on the file system, or maybe distributed file system, maybe a service with an HTTP API that you send blob to it and you can retrieve blobs from it. But that's storage, basically XML files, if you think about it, or if you want them to be JSON or maybe proto buffs or some other formats. Parquet is a modern one, etc. Well, that's storage. And we knew how to solve storage with computers well before relational database systems were invented. And RDBMS, they're not solving storage. They're solving concurrency and isolation. In short, those concepts are nowadays well known around the ACID thing. ACID means atomic, consistent, isolated, and durable. And that's the four main guarantees that you have in mind when you're using a database, which is tricky because with the NoSQL movement, a lot of database solutions that are not relational and that maybe provide some form of SQL, but mostly not. So the NoSQL movement, they made some interesting trade-offs in the ACID capabilities of the system that you need to have them in mind as a developer. So in this first part of the presentation, we'll go through what does it mean to be ACID. The first thing is atomic. Atomic means that when you send some work to do on the database, let's say one insert and two updates, you can wrap them in a transaction. And then we say it's atomic because either the three orders, insert, update, update, the three of them did happen or they did not happen. It's not possible when you use a transaction that is atomic. It's not possible to have only the insert go through, but not the rest of the transaction, which is huge for your application development processes, because then you don't have to think about what happens if only the insert makes it through. Then my schema, my data, my schema doesn't mean anything anymore. The application will be broken because there is no way that this makes sense. We only have a part of the rights we wanted to do. So what's next now? So usually when you think about atomic, what you can think about is rollback. So if you do insert, update, and then there is a file system is full error, then when you commit, the answer is, oh, I'm sorry, rollback because I couldn't make it happen. Usually as a developer, we don't include rollback in our code or don't type it in interactive terminals. Rollback is more often the result of file system is full or some other mistake that happened, like division by 0, and then you commit, oh, sorry, rollback, things like that. If you think about it, PostgreSQL is very good at one thing that it's almost the only system that does that. You have atomic transactions for DDLs. DDL is data definition language. It means create table, alter table, create index, all those things. With PostgreSQL, you can roll back the schema modification. So let's say you have your application deployed in production, version 1, and you have an upgrade script, migration script that goes from version 1 to version 2, and you deploy that in production. But in the middle of the deployment, you have like file system is full. That's kind of my favorite error there because it's very easy to relate to it and understand what it means for you. So you run the schema and file system is full in the middle of it, like you're adding a new index, but you don't have disk space for the new index. What's next for you? Well, if you're using PostgreSQL and you've been careful to put your migration schema changes into one transaction, what happens is rollback. I'm sorry, you're back to version 1 because we couldn't make it happen to go to version 2. If you forgot to use a transaction or you're not using PostgreSQL, what happens is that now you have a part of the schema that were applied on top of version 1, but you didn't reach version 2. So now you have something in production that is neither version 1 nor version 2, and that no developer of the application ever saw anywhere. So good luck with that. So what kind of application code are you going to plug on the schema of the database that nobody had seen, ever before? So that's transactions for you, and with PostgreSQL, that includes DDL. When you're atomic to be ACID, you also need to be consistent. Consistency is often enough explained in terms of constraints. When you hear the term constraints, or when I do at least, I don't know about you, but for me, I don't really want constraints. I like to be free. And so most people, they think about constraints in a bad way. They're like, yeah, constraints, who cares about constraints? In a database world, a constraint, what it is really, it's a guarantee. It's a strong guarantee. In our slide here, we can see that we have a very simple table named foo with two columns, ID and F1. ID is integer. If you try to insert into the ID column the word, for example, banana, or anything else that doesn't look like a number, PostgreSQL is going to error out and tell you, I'm sorry, you said you wanted a number. That is not a number. In some other systems, they would say, oh, warning, it didn't look like a number, so I've tried to be helpful, and now you have 0 instead. So do you want one or the other behavior, or maybe you want to debate about it? What I will tell you is that if you want to be consistent in the terms of ACID and the usual expectation of SQL, well, if it's consistent, either it's an integer or it's not, and then it's an error, and it's not expected. You don't want it. You don't want to have to deal with this data that was not qualified the way you thought it would be. So that's consistency. The first level of consistency is the schema design and the data types you're using on top of this schema. On top of that, we also have constraints in SQL. So check, not null, primary keys, foreign keys, and things like that. The fact that we have foreign keys doesn't mean that we are relational. Relational means that in a table foo, we have a relation because every row in the table is going to look the same. It's going to have the same numbers of columns, and all of the columns are ordered in the same way, and each of them is of the same data type. That's what is a relation in mathematics, and also in the relational model. Foreign keys is something else on top of that. For ACID, you need also the I for isolated. Isolation is kind of the other side of atomicity. They go well together. Remember, atomic, we said, if you do insert, update, update, then you can commit the whole of them as one unit of work. It's 0 or 1. It cannot be in the middle. Isolated is, as soon as it's committed, can I see it? Can I see what the other guys are currently doing on the system? So if you think of pgdump, it's going to take a backup of the database, an export, and it needs to be consistent, which means pgdump doesn't want to see the new data that is making it to the database while it's running. So that's where concurrency and isolation begins to really make sense. So during the whole duration of your pgdump, if you have a big database, maybe it's going to take, I don't know, 4 hours. Well, during those 4 hours of time, while pgdump is running, pgdump doesn't want to see any change in the database, but maybe your application still wants to make changes. So pgdump is going to take what we call a snapshot. It's like in a movie. If you stop the movie, then you have a snapshot. The image doesn't move anymore. It doesn't mean that the movie stopped. It means that you're not playing it. Maybe someone else is playing it, but you are not. That's what happens with pgdump. Pgdump will stop the movie, fetch the database as it is at this exact snapshot, while the other users of the system are making progress. You have, in the SQL standard, 4 different levels of isolation, and the PostgreSQL default one is read committed, which means as soon as someone else did a commit, you can see the commit they did. But maybe you want read committed instead, or even serializable, like pgdump is doing. So as an application developer, you can have that choice, and you can have transactions of different kinds being run in the system at the same time concurrently. So that's pretty powerful. And the last guarantee of ACID that you want to have is the D, durable. Durable means that as soon as the data has been committed to disk, the system is not allowed to lose it. So you have a strong guarantee that if you got the commit message back from your commit command, well, then it's on disk and we're not going to lose it. So you can hard reset the hardware, you can reboot, you can do whatever you want. The data is safe. You will retrieve it again. That's why some people think of RDBMS as storage because of the durability. But it's only one of the four main things that you want from an RDBMS. So why are you using PostgreSQL as a developer? Because the first reason why, as an application developer, it's interesting to use PostgreSQL is because it offers you all the ACID guarantees. It implements transactions so that you don't have to implement them in your application layers. To benefit from transactions, without having to rewrite it in your application, you need to be able to send some computation in the database at times. And that's why we have SQL, the query language. The idea is that some of the things you want to do, they need to run within a transaction boundary. And to observe the transaction boundary, you need to be able to send the computations down to the database system. And you do that using SQL. It happens that I like SQL, and I will try to share some of the reasons why with you in the following of this presentation. It can be argued that SQL is object-oriented in the implementation that PostgreSQL provides you with, and we might see some details about that in that if we have time today. PostgreSQL also has extension and rich data types, and we will see more about that in a moment. You can do some of the data processing you need within the boundary of a transaction in the database server, so it's very nice. And basically, if you want a shortcut with all that, PostgreSQL is going to implement a lot of very advanced technologies and concepts and tools that you need to develop your application in a way that you don't need to do them again. So you're going to win a lot of time using PostgreSQL to reach a good system in production without having to yourself write the code for it. So usually that's why it's interesting to use Postgres. So that was the first part of this presentation. Like to get back on our feet again of what's the context around PostgreSQL as an application developer? Why is it interesting even to talk about it? So I hope I answered that question now. For the second part of the presentation, we're going to dive a little more into what you can do with SQL, because I've met with a lot of developers that are using SQL on a daily basis, but without realizing the full power behind it. And it's very powerful. It's not just insert and update. It's not just a group by. It's more than that. So let's see about it. To be able to see some SQL examples, we need a data set. So let's pick this one, the New York Stock Exchange data set, because it was easy to download. It was available as open data, and it's easy to understand for everybody involved, usually. So I hope it's going to be easy for you too. Usually it is. So you have a year, then you have the full date, and then you have three numbers which are representing what happened in the New York Stock Exchange that day, which are the number of shares, the number of trades, and the amount of dollars that changed pockets that day. Thing is, the file that we are provided with, it's a kind of a CSV-like file, but the numbers are written in a human readable form, so with a comma to separate the thousands and with the dollar signs for the dollars. So what we're going to do here is that we're going to say it's text, we're going to import the data and then change our mind about the numbers being numbers rather than text. To load the data in, I've been using the copy command, and here it's written \copy because it's the client-side implementation of copy in the tool named pSQL, the console tool that you use in the command line. Copy in PostgreSQL is more than a command. It's also a streaming protocol. If you are writing an application in Python or Java or Go or whatever you're using these days, you can access to the copy protocol and you can open a file and send its content line after line without having to prepare a huge insert statement around it and things like that. You can just send the data in a streaming fashion to PostgreSQL, and PostgreSQL is going to process it, online in streaming fashion as it goes. So that's pretty powerful. And when we have the data on the server, then we're going, as I said before, to remove the commas and the dollar signs and make it so that the numbers look like number, and then change them from being text to being the number that we intend them to be. And for that, we are going to use alter table statement, and we are going to rewrite the table only once. And in that one rewrite, we are going to replace 3 columns from text to big int or numeric. So there are other ways to do it, but this way is important for me because it allows me to show you that you can do within a single alter table 3 modifications at once. If you have a table with already like 1 terabyte of data, maybe rewriting this huge table once instead of 3 times, it's something that is going to be important for you in production when you deploy new schemas or things like that. So knowing that you can do more than one thing in a single alter table statement, that's a good thing to know. Some objections that I hear from developers that have to use SQL and they don't like it is that when they write the code themselves, they can, choose the best algorithm for the job, whereas in SQL, it's hard to know what's going to happen on the server. So let's dive into that topic. On this slide, I'm showing you a top-N Ipsort done in Python. The idea is to retrieve the top 10 rows of the whole history of New York Stock Exchange that we have loaded, where the number of shares exchanged that day are the highest. And we don't want to have the whole thing in memory in our Python script at once. What we want is, because we only want the 10 top entries, we figure out that we might be able to do that with only keeping 10 rows in memory at a time. Turns out that doing this is named Ipsort, and there is a Python library in the standard distribution of Python that is named ipq that you can use. And so you can ipify a list and then use the ippushpop function to then only maintain 10 elements in memory at a time. And at the end of the script, you output the result that you see with the top 10. And writing the code that way, you make sure that at all time in memory, you have only 10 elements, not 1 million or 1 billion of them, depending on the size of the data set that you are dealing with. So how do you do that in PostgreSQL, in SQL? Well, in SQL, that's how you do it. You do order by dollars, limit 10, and you have the same result. So how do you check that PostgreSQL is using something smart and actually keeping only 10 entries in memory during the duration of the query, rather than adding up all the table data into memory and then sorting it and then getting the top result? When you want to know what PostgreSQL is doing with your data, you can use the explain command. My favorite way to use explain is explain analyze verbose buffers. Analyze means PostgreSQL is actually going to run the query for you, and also on top of it measure the time it takes for each and every part of the execution plan. If you're not used to reading an execution plan like on the slide now, it might be a little difficult to wrap your head around it. Please take some time and get used to reading them. The more you do, the easier it gets, and then you can spot things really easily. There are a couple of online tools that are very, very nice on top of that, and will help you through learning how to do it in a very visualized way. So that's very good too. Here, I've put one line in bold, which is sort method, top-N Ipsort, with the memory used during the whole duration of the query. So we can check that, yes, the whole code we wrote in Python before, it's actually what PostgreSQL will do server-side when you just do order by limit. So 4 lines of SQL is all you need to do to guarantee that you will have an Ipsort. So that's pretty nice. Usually, with this kind of data, one of the first tasks someone will ask you to do is a monthly report. So here is how it looks like in SQL. It's pretty basic. So if you're listening to this presentation, I guess that you already know how to do it. I've been using 2 Char to have a nice display. And the thing is that you can see that we set the start variable to a value here. This is actual code that you can use with the pSQL tool. So if you're used to using pSQL at the command line in the terminal, you can actually do that and then have a variable that then you reuse later in the query. But the main important thing here is that we don't use between for dates, because usually when you use between, you know that between is inclusive. So if you give the start and end date, both of them are computed within the between restriction, meaning that it's very easy to have a bug where the last date of the between interval is actually the first date of the next one, and so this date has been counted twice. So to avoid this bug and lots of back and forth with the accounting department, just use explicitly inclusive and exclusive boundaries in the where clause. And also you can ask PostgreSQL to compute the end of the month for you, because here it's a February month in a year that is not a leap year. So do you want to have to compute that yourself in the application, or just say to PostgreSQL, hey, stop just before the beginning of the next month, which is like less than the start plus interval 1 month, and PostgreSQL knows how to do that for you. So here is the result, what it looks like. No surprises here. It's very quite basic what we did. Still, there is a bug. Some people might complain that this month of February had 28 days and we only have 19 rows. What happened with the other rows? So what happened is we don't have any recording of those rows because there were no activity on those days. The missing days are days without activity. So can we now please make a monthly report that includes the days without activity? Here is how you do that in Python first. Because if you don't know how to do it in SQL, you do it in Python, if Python is your application development language. Here you can see on the left that we are just, doing the query the same as before, and then swallowing the result in memory. And then on the right, we are going to instantiate a calendar in Python with the iter month dates API. And then we're going to scroll through the calendar, and if we find that for a given day we have in our result set some data, then we're going to use it. If we don't, then we're going to output 0 instead. So basically it's a hash join, because we created a hash on the left part of the slide, and then we are probing into the hash for each date of the calendar to see if we have a result or not. And when we do, then we can display it. Otherwise, we display 0, and here is the result. So now we have the 28 days. Well, it turns out that implementing a hash join and filling in the blanks when there are some blanks, it's very easy to do in SQL. Before we get there, why would you do it in SQL? It was easy to do in Python, right? But maybe you will have this days without activity problem to solve in more than one place. Maybe the front end needs it, maybe the back office needs it, the finance department, the accounting department, the invoicing. Maybe everybody has a different way to do it, where they need to have a listing with the days with no activity. The common thing about all those things is that the data is in PostgreSQL, so that's the big elephant on the slide. But in a lot of companies with some history, well, different parts of the tooling are done with different technologies. So in our example here, we have some Django application. So Python Django, maybe that's the new front end, and maybe the back office is still written in Java, or maybe it's the other way around. We don't know. Maybe there are some quick job done in PHP, and some guys was trying Ruby on Rails rather than Django, but it made it to production somehow, or I don't know. We can invent a story around those little drawings. The important part is, will you have to solve the same problem more than once in different stacks? And if yes, can you guarantee that the calendar libraries included in Python, Java, Ruby, and PHP are going to be the same with respect to leap years, maybe even leap seconds, and other kind of computation that you need to do when you look at the calendar, and the calendar is pretty complex. So from, again, discussion with developers that are running in production with mixed environments, I can already tell you that for Python and Java, the default calendar solutions are not going to always be compatible. So maybe there is some value for you to use PostgreSQL instead. So let's solve the problem in SQL. Here is how it looks like. It's basically the same query as before with a trick, that two of them. First trick is that we are going to use generate series. That is going to, in PostgreSQL, usually the name of the included functions, the built-ins, the names are not very poetic. It's rather to the point. So generate series is going to generate a series. And it's going to start with the first date and end with the last date that we compute here as being the 1 month later minus 1 day, because this time it's inclusive, so we don't want to have a bug there. And we are going to generate a new entry in our series on an interval of 1 day. And we want to keep the calendar dates, whether or not there is activity in the fact book table. And we do that with a left join. And that's going to be implemented possibly as a hash join, exactly the same algorithm as we did in Python. But now it's easy to reuse whatever the stack around it is. And we can see the results. Unsurprisingly, it's the same as before. It's not very interesting. The next step, if we have a marketing department we talk with, it's a classic. We want week-on-week evolution. So maybe it's not clear for everybody what that is. So let's see the result of the query first. I have added some colors in the slide. And so you can see that Wednesday and Wednesday, but maybe it's not the most visible. So maybe like Monday and Monday that are in bold. So from one Monday to the next, we saw a 3% increase. And then the next Monday, null because there were no activity that day, etc., etc. So we want to compute the percentage, the difference in percentage in between the same day last week and the day, the current day. Here is how to do it in SQL. On the left, you can see the same query as before with the generate series and the left join over the fact book table. And we use that in a with subquery. It's called the common table expression. Common table expression are standard in SQL, and you can basically give a name to any result set. In SQL, a relation is like a set of data, like I told you, with a certain number of rows. We don't know that, but always the same number of columns in the same order, and each column of the same data type over the whole set of data. That's a relation. So any query is going to give you a relation. As soon as you run a query, the result of it is a relation. That's why you can use subqueries in the from clause, because the from clause that we see on the right of the slide here, the from clause is going to work with the relation. And the result of a query is a relation. So we can use the computed data on the right of the screen again, and go through the computed data and compute the percentages, the differences. And to do that, we are using a window function. So I won't explain everything in detail, but basically a window function allows you to see another row from the result set, and you need to specify which. You're building peer rows that you are friend with. They are your peers. So you need to define with the over clause which rows you want to see, which rows you're friend with. In this case, we are friends with any row which has the same ISODO as us, because we use partition by extract ISODO from date. And we order them by date, so we can see them in a specific order. ISODO means day of week by the ISO standard, because there is more than one way to compute that. And given that a list of peer rows, we're going to use the lag function to see the one before us. So if we have the same day of week, it means we are both Wednesdays or maybe both Mondays or something like that. And we can see the one that is also a Monday. And when we order them by date, it's the one that lags one entry before us. So it's the last Monday or the last Wednesday, whatever the current day is. And then on the right, you do a very simple percentage computation, and there you have the result, which is a straight copy-paste from the PSQL prompt. Window functions were in the SQL standard of 1992. Most developers or people I've been talking to when they have been taught SQL, they've been taught SQL 89 or sometimes 92. The current standard is 2016, and there were a lot of new things. So maybe you don't want to learn everything about SQL, okay? But SQL 92, it's a long time ago. It was at the time where we invented like IPv6 or maybe Unicode, things that everybody takes for granted nowadays. So maybe it's time that you sharpen up on your SQL skills. If you think window functions are new, they are new from 92 in the standard. Okay. So what I'm saying basically is that you can code in SQL. You can write part of your application code in SQL. But to be able to do that, you need to be able to think in SQL. If you think within the Unix framework, in Unix, we say everything is a file. So if you want to print something on the printer and have a piece of paper go out of the printer with information on it, you can send a PDF file with the cat utility over the /dev/printer file, and things will happen that way. When you connect to a network in Unix, you will have a file on disk, like a socket or something. Everything is a file in Unix. In Java, they say everything is an object. So if you think in terms of Java, you need to think in terms of objects, and all they relate to each other. If you're using Python, you have objects too, but you have other things that you have to think about, like packages and modules. In SQL, if you want to think in SQL, you need to think in terms of relations, and you need to play in your mind with relations that you can compose. To define a relation, well, you do a select. Select is going to introduce the list of the columns that you want, and so we call that the query attribute domains in SQL, and the select operator is named the projection operator, but you don't need to know everything about that. You just name the columns, and SQL will see what data types it is. It will infer the data type as in strongly typed programming languages like Haskell or OCaml or other languages, where there is a type inference system that decides for each variable which type it is. Well, SQL does exactly that with your columns automatically for you. And that's the select part of the query. When you reach the from part of the query, then you introduce base relations on which you're going to fetch the data from. And it could be also computed relations. So a subquery, again, any SQL query is a relation. So a subquery is a relation, and you can use it in SQL to compose your query that way. And then you have joins, and then you have set operators and things like that to define a SQL relation. I won't have as much time as I wanted to, so I will not detail exactly this slide, but basically the idea is to put in bold things that relate to the concept of relation in SQL. So have a look at that, it's interesting. And the query itself is a left join lateral subquery that is nice because it allows you to have a top 3 in that case, sorry, a top 3 of all the pilots of Formula One over the whole history of Formula One per decade. So in the 50s, it was Fangio. So it's a nice trick, but unfortunately, I can't dive into it just now. So I'm trying to say that SQL is code. If it's code, then maybe you want to have, a developer tooling around it. On the left of the screen, it's one of the queries we saw before. Just to have in mind that we're dealing with a query. So maybe the best way to do it would be to have SQL files in your repository, in your code repository. You have py files if you're doing Python, Java files if you're doing Java. Maybe you want SQL files and play around with them. So how to do that? And then how to organize your processes around SQL, maybe with unit testing and regression testing. So here is, some people, when they want to integrate SQL, they use ORMs. But I keep saying that every SQL query provides you with a result set that is itself a relation. So the R in ORM should be mapped to the result of the query. If your ORM does that, then it's going to be very nice to use it. If not, you will have trouble. Simple as that. To integrate SQL in code, let's have a look at a nice solution that exists for Python and exists also for many other languages. This example is in Python. So we have a SQL file here with comments around the queries. And then you integrate this file here with the load queries function of the library. And then all the queries, they're given a name, which you can use as a method name or a function call name in your programming language. So it looks like calling a function or calling a method, where it's actually going to use the SQL query, inject the parameters into it, and send it to PostgreSQL. So you can now develop your code, the Python side in Python, and the SQL side in SQL. And that's very easy to do and integrate. So it's a very nice way to do it. And when you do it that way, it means that in your code repository, you have a bunch of SQL files that you can use. And then I've written a little tool called RegressSQL. It's inspired from PostgreSQL regression testing facility. And what it does is, you register, let's see about that. You register the query plans that you want with basically for each query, you give a list of parameters. And then you run the tool. It's going to output the result of the queries for you, each in a file. And you can store them as expected. But the next time you run it, if you've changed the query, well, we're going to verify that the result is still as expected. Simple as that. And if it's the case, your tests pass. If it's not the case, they fail. So you have regression tested SQL integrated into your application. So it's easy to do it if you want to do it. And to finish with this presentation, I still have 1 minute left, but maybe I need a little more. PostgreSQL extensions. We can do geolocation directly in PostgreSQL. Here we are using an operator that reads a little strange, but if you think about it, the first time you saw equal as being 2 horizontal bars, there is no way you could have guessed. So this one reads contains, and we can find in the database all the entries that are going to contain that IP address. With PostgreSQL, you can have an exclude facility here. It's an exclusion constraint. So it's like a generic primary key constraint or uniqueness constraints. You're going to say that you want to have IP ranges But if they overlap, this operator here is read overlap. When you have IP ranges that overlap in your dataset, you want to exclude them. Usually you do that with equality. If they're the same, I want only one of them. Here it's with overlapping. If the IP ranges overlap, I want only one of them, which means that in the next query, when we do that, for a single IP addresses, because I guarantee that I don't have overlapping on the dataset, I guarantee that there is only one IP range that contains this IP address. And then this query was the query I used some years ago when the conference was in Dublin. I loaded from OpenStreetMap all the pubs in the UK. And then the IP address was the IP address of the hotel the conference was given in. And with that query, we could find a list of the pubs around the conference hotel very easily. And at the time, it ran like in 3 milliseconds on my laptop that is optimized for traveling, not for query processing. So you have more time to actually do a nice display on the map or something like that. And I had another query, and for sake of timing, I'm going to skip over it pretty quickly. The idea is that when you have a data set that you don't really know much about, in the previous slide, it was like the NBA, so basketball games with defensive rebounds, and we can see that some games are unusual in the numbers of defensive rebounds with having 14. You can use a query like that with a MVC, Model View Controller, with a controller here responsible for outputting a very nice bar diagram directly in your console as the result of the SQL query without needing anything fancy on top of it, like advanced graphic frameworks or things like that. It's just SQL. And the query before was showing 14 as a number, and we can see that 14 is very out of the ordinary. It's usually 25 to 35. We can see that like on the spot, thanks to displaying the result that way. So that's the kind of things that are pretty easy to do when you're used to using PostgreSQL and the awesome SQL support that is provided for you within this very nice database. So that's it. That's the art of PostgreSQL for you guys. Hope you liked the presentation. Bye.
Wow, that was great. Thanks a lot, Dimitri.
Thanks.
So
thanks.
we got a pile of questions here. The first few are regarding your book. So
yeah.
Let's handle those.
Sure.
Couple people are asking, how do they buy your book?
There is a website online. I'm going to try and copy paste directly in the chat area. I hope it worked. So it's called theartofpostgresql.com. You go there and there is a checkout process, and you can copy paste the coupon that I mentioned in the book.
Fantastic.
Using the checkout process on the website.
Awesome. Thank you. The other question we've got here from Charles Mark. He asks, I purchased the full edition of the previous version of the book. You're mastering the art of PostgreSQL in AppDev.
Yeah.
And he's planning to purchase the new version, but he's wondering about the content, if the queries in the databases are the same or if they're different between the two versions. Should he purchase the full version again, or is it enough to just get the update?
That's a very good question. So it's a new edition of the same book. So it's basically a new packaging of the same content, plus one new chapter, completely new, in the book. So people who got the first version, send me an email. You have my email on the website and everything. It's dim@tapway.org. But go to the website, you have it in the bottom. Send me an email, and I'll give you a very nice discount to upgrade to the new edition, because most of the content is the same. Not all of it, but a fair amount of it. So I do that. Just send me an email. Yeah, thanks.
Fantastic. All right, so Brett Smith here is asking, could pgLoader be used for migrating one PG schema to a modified PG schema? And should it be used that way, or is there a better
Yeah.
tool or strategy you have in mind there?
It can be used that way. We added the feature some versions ago. So now you can have a source and a target that are both PostgreSQL, and you can have different schemas. So it's one way to do it. It's a good way to do it if you have like for integration purposes, like if you have a CI/CD system and things like that. Some people want to focus on the maintenance window it represents for the new data to be available if you need to shut down the writes on the old table and things like that. In that case, I have a look at pgLogical or other solutions like this. But it's just a tool, so it's very hard to say upfront if it's the best tool for your situation without the exact situation you have in mind. So it's just a tool. It can be used that way, yes.
As with so many things, try it and see.
Yeah, exactly. Yeah, it's a good one. Yes.
All right. Well, Fabian's asking, how do you handle test data using RegressSQL?
So in RegressSQL basically is a good prototype. Play around with it. If you like it, you can improve it. Or it took me like a couple days to write it. So really, if you like it, but it's not exactly what you wanted, make it better, either from scratch or just improving it. So you have a YAML file where you have the input of any SQL that is going to be executed during the tests. So it's called the plan file, and you can plan the tests. And for each and every query, you can have one or many different series of inputs that are going to be used and then tested against the output that goes with it.
So a quick digression there. This is one thing I really appreciated about your book and is reflected in this little library too. It reminded me a lot of the Pragmatic Programmer, if you remember that book from a couple decades ago. They just came out with a new version, by the way. But
Oh, nice.
it is a heavy focus on not hewing to somebody else's opinions or needs. It's taking the tools available to you and adapting them to your needs. And I think the answer you just gave follows right in that vein, where you've provided an example of how to do something, but the expectation
Yeah.
is you'll adapt that to your situation.
Yeah, if you look at Docker and Kubernetes or PostgreSQL itself or some other software, it can be very complex to do it again from scratch. And then you don't even think about, should I use Postgres or rewrite it? That question is not really meaningful. But if you look at just, a tool to run queries and compare the output of them, yeah, sure, just, tailor it to your exact needs. Yeah, that's a sound process for me. Yes.
All right. Well, we got a specific question here from Ramesh. He's asking, any fully functional tool to migrate Sybase to Postgres?
So pgLoader that I mentioned at the beginning of the talk is one of the tools I've been working on. It supports Microsoft SQL Server because someone paid us to contribute the feature. It turns out that Sybase and SQL Server have a lot in common, and they use the same protocol and they use much of the same things. So I expect that pgLoader would be able to connect and do most things with Sybase, but maybe not the whole thing. I'm not sure. So it's again, try it and see. That in that case, redoing pgLoader from scratch, maybe it's better to contribute to it. And you can either contribute to the code directly. It's on GitHub. It's open source, same license as PostgreSQL. So you're welcome to join the team and contribute some features. And if you don't have the skills or the time, you can always contribute financially so that someone else will have the time then to do it. But it's open source as usual. So yeah.
Excellent.
So maybe it
It's a
works.
good starting point.
Yeah, exactly. It speaks the protocol at least, and it knows some about the schema, the catalog queries for SQL Server and Sybase. I'm told they're not that different. So with some luck, it just works.
So along those same lines, Bindu is asking if you can recommend any good tools to migrate an Oracle database to Postgres.
So I have two answers to that question. First one is there are a couple tools that exist in different ecosystems, like different cloud providers are embedding wizards that are going to to do that for you, like database migration tooling. So if you're on a cloud provider, check that out. There are a couple open source tooling around it too, like Array2PG and other things. So check that out too. Nothing is going to be the complete migration for you. So I wrote a quick white paper about how to migrate from one database to another. And basically you have four things that you need to care about, and the data is one of them, but the code is another one. And in Oracle, usually you use storage procedures a lot because it's part of the architecture. This part is very hard to migrate currently, the tooling in open source. I've not seen that yet, but some of the proprietary offerings are going to help you through that too. And the other part of the answer would be, I think for starting with this task, it would be like for implementing SQL Server support in pgLoader, it took us a couple of weeks. So maybe to implement Oracle support in pgLoader is going to take us another couple of weeks. I don't know. We didn't try it yet. But I would expect it's the kind of effort we need to put into it. So if you would like to have pgLoader, but for Oracle, just talk to us on the GitHub site, see about the sponsoring, and let's make it happen.
Awesome. I'm obliged to mention at this point that EDB offers their own services and support for Oracle migration. If you go to the website, it's like one of the first links on the page. So check that out too. All right.
I didn't want to name names, so I'm happy you did it.
No, I totally understand. Got to get a plug in though. Okay, that almost wraps it up. We have one more little question here. If I can find it, I screwed this up. Oh, here we go. Vic asks if we can get the book in French.
Oh, so some people keep asking that because they realize, thanks to my accent in English, that I'm not native, and then they figure out I'm French. And it's a lot of work to make it happen. So we are running a pre-sales for understanding the interest behind it. Like, is it worth the effort? For now, only a very few people have expressed interest into buying a French version of it. Not enough that we would start the work, unfortunately. So if you're French or you know French people who want the book in French, it's possible for us to translate it. I'm French after all. But we need to have an audience to buy it then, because it's a lot of work. And yeah. So at the moment, it's not on the schedule yet.
Awesome. Well, thank you so much, Dimitri. This has been
my pleasure.
A fantastic little conversation, and your presentation was very informative and enjoyable.
Thank
you
very
for
much.
joining us, and thank you to everybody who participated in the chat and submitted questions and answers. And I'll let everybody get on to the next session now.